Okay, hello everyone, and welcome to our newest webinar, How to Build Complex Calls to APIs Without Writing Any Code. This is the newest installment in our webinar series that explores using APIs, web services, and anything HTTP with FME. So today we're going to dive even deeper into REST API. This content is intended to build on our previous webinar, how to connect to an API without writing any code. But this time around, we're going to assume that you feel comfortable with that material and are interested in taking your API skills to the next level. But if you'd like to watch or review part 1 of this series, you'll find the link in the slide to that one and many other webinars that might interest you. But today is all about APIs, and we're always trying our best to cover common scenarios or challenges FME users encounter. So your feedback is really important to us. So in that spirit, we're going to start off with a poll. And our first poll is, what is the toughest challenge that you encounter when working with APIs in FME? Would that be confusing REST API documentation, maybe settings on the HTTPCaller, authentication issues, parsing a JSON response? Let us know, select the ones that you think apply to you. And if we missed any, please just chat them out because we definitely would like to hear about it.
Sinai, what do you find difficult about working with REST APIs? Like, what was the hardest thing when you got started?
Probably deciphering REST API documentation. Yeah, that can be a challenge. They're often different. So it's like learning a new language each time. What about you?
Yeah, I think for me, it was parsing JSON and kind of getting my head wrapped around it. I thought that was quite difficult.
Yeah.
So we'll leave this poll up, I think, for a little bit longer. People are still trickling into the webinar, so we'd like to give everyone a chance to enter the poll before we get fully started. But it seems like all the challenges we've outlined, there's someone interested in. Like, there's definitely no clear winner here. Authentication issues is getting a lot of votes.
Yeah.
The most votes, but parsing JSON and using REST API documentation are just shortly behind that.
Okay. Yeah, authentication issues in first place, but a pretty even split here. Okay. Good to know. Okay, thanks for feedback, everyone. We hope to address some of these issues during this webinar, so let's continue on. Before we jump into the content, though, let's have a quick introduction. My name is Sinai, and I am an FME Server support specialist, and I'm here with my teammate, Sienna.
Hey, Sinai, how are you doing today?
Pretty good, pretty good. She's also an FME Server support specialist, and we are pumped today to talk about REST APIs. We had a lot of fun putting this together. Over the next hour, our goal is to show how you can translate complex API calls into manageable and easy to understand FME workflows. So we're going to take a deep dive into that HTTPCaller transformer and introduce some of its advanced settings. Then we have a series of topics planned. So we'll explore API query languages with Socrata. Then we'll discuss those unfamiliar curl examples that we often see in API documentation and how to translate them to the HTTPCaller. Then we're going to move on to how to build custom web tools with custom transformers. First, we'll do a little introduction to them, and then an in-depth example that demonstrates pagination. And if you're already wondering what pagination is, or curl, or custom transformers are, don't worry, we're going to start pretty simple and have a demo for each of these topics so you can see it in action. And this could sound a little ambitious to cover all this, but we're just excited to demonstrate everything you can do with APIs and FME. So to back up a little, in case you aren't familiar with FME and you're wondering what this means, let's just introduce ourselves. At Safe Software, our mission is to help organizations maximize the value of their data, no matter where it's stored, what applications you're using, and who you need to provide access to. So as server specialists, Sienna and I are often supporting customers as they explore how to best automate and integrate their data. The platform we are supporting customers with is FME, the data integration platform with the best support for spatial data worldwide. From desktop to cloud to mobile, we're going to help you build, automate, and deliver your data workflows. And our first aim is to connect data from a variety of different sources. And off the bat, we support well over 400 formats, but this expands by an infinite amount when you consider web services like we are today. We also provide the tools to perform a range of transformations from data validation to manipulation, analysis. There's just so much you can do. And then the final stage is to automate these integrations, whereas that's when us server specialists start getting excited. So now that we have your attention today and our topic is APIs, we wanted to take this opportunity to talk about some of the advanced and new features on the HTTPCaller and how you might integrate them in your workspaces. So admittedly, using cookies is not new, but it's often misunderstood or maybe underutilized. So let's just take some time to talk about it. So a cookie is just a small chunk of unique text data that clients and servers pass back and forth inside HTTP headers. So the diagram shows a very simple example. Our client first makes a request to a website. The website might say, hello, nice to meet you, here's your personal cookie. And while you're there, and anytime you come back to that same website, you hand this cookie back so that the website recognizes you and customizes your experience. In FME, most times we will use cookies for authentication as it keeps you signed in after you log in. But there's other reasons that cookies are used. It might be to load your preferences. Third-party cookies may collect and pass information about your browsing habits. For better or worse, a lot of our web experience is actually quite personalized due to cookies. This is why after you clear your browser cookies, you're logged out from all of your websites. Your settings have changed. It's like you're starting fresh. It's because you have to reintroduce yourself to all of these websites again and get a new cookie. The HTTPCaller doesn't automatically save cookies, and as it is, it's kind of like you're clearing your browser cookies after each call. So to turn them on, just select Save Cookies under Client Options, and with that, you'll be able to maintain a session and remain logged in no matter how many HTTP callers you have connected. So most of the magic happens behind the scenes as cookies are passed in the headers. Those aren't visible unless we choose to expose them. So if you're curious, set a list attribute name for your headers. If you can see in the green arrow there, make a call to a website, say even google.com, and view the response. In your feature information window, we will find our cookie and its value in our list attribute. And if you keep making calls, this value will remain the same. Next, I'm excited to introduce the concurrency setting. If you're using HTTPCaller and not thinking about concurrency, you might not be fully optimizing your workflows. Concurrency is when multiple requests are sent and processed simultaneously. So in our high concurrency example up top, there's several requests being sent all at once. In the bottom low concurrency diagram, there's only one request being sent over that same period. So we can assume that the top workflow would be much faster. Now that we can control how much or how little concurrency our HTTPCaller has, you might be starting to think about how this could speed up your workflows. Imagine you have a workspace where you're processing lots of features. If you set concurrency to 1, there might be a bottleneck as each feature arrives at the HTTPCaller and waits for the feature ahead of it to finish its request. If it's a slow server or you're sending or downloading files, this could take a long time. So if you raise that maximum concurrency, these features won't wait. They'll get set right away until the maximum number of requests are in progress. So as a disclaimer, a lot of servers have a threshold, and refer to the documentation to make sure you're abiding by those rules and not slamming the server with requests. There's a lot of good reasons, though, to set concurrency to just 1. For example, when looping with custom transformers. And if that interests you, we're actually going to touch on that exact scenario a little later in the webinar. But now let's see the power of concurrency in action. So here we are processing just over 100 features in our workspace. On our left, we have concurrency set to 50. As you can see on the feature count number, these requests are completed in batches of 50 quite efficiently. On our right, concurrency is set to 1, so only one feature enters and exits the HTTP caller at one time, and this will take a lot longer to do. While concurrency controls how many requests can be sent simultaneously, rate limiting overrides that by controlling how many requests can be made over a given period of time. So in our diagram, we see multiple requests waiting for a timer to let them through. If the rate limit is 1 minute, each request will wait that whole 1 minute before proceeding. If the rate limit is just half a second, you might not notice a difference at all. So this really prevents you from bombarding a server with more requests than it allows. Exceeding the server thresholds can throw errors or even result in a block from that error or from that server. So we don't want that. So we're really happy to say that the ability to control rate limit is currently in our beta version. So please check that out. Now we're going to switch gears and jump into some workflow scenarios. To start, we're going to show how we can use database-like query languages with our requests. So because APIs are an efficient and easy to manage method of allowing users to request information, there are APIs that function somewhere in between a web service and a database. Socrata is a really good example of this, commonly used by governments. This platform is made of tabular datasets that can be accessed via their API, SOTA. So if you'd like to know even more about Socrata than what we touch on here, we have a webinar that highlights our reader and writer that are purpose-built for interacting with Socrata, and those are both linked on the slide. But we're going to use HTTPCaller with SOTA so that we can explore exactly how these query languages work and how they translate to our workspaces. So since it's a database, it only makes sense that API parameters are built like a structured query language, so SQL. SOTA datasets conform to a structure with standardized data types and fields that allow for more enriched request queries. So the building blocks of SOQL requests conform with the standard HTTP request structure, and they're perfectly adaptable to the HTTP caller. There's just a few things to know. We have a domain URL, we have a path, a dataset identifier, and in our parameters, we start with a clause, which is a conditional statement like the SQL where or select. And this is kind of where we depart from classic API query parameters because it's often combined with a function. Functions allow you to perform small tasks within your queries. So we use similar functions in databases or Excel that you might be familiar with. And under the diagram, there's a more classic example of using a round function that first intakes the number or field to round, and then the 2 digits to round it to, which this example is exactly 2 digits, and then produces a result. So most functions intake parameters in a specific order just like this, and it's important to refer to the documentation, as usual, to see exactly what the parameters are and in what order they need to be entered. So for this demo, we're going to use the City of Calgary Open Data Portal powered by Socrata. One of its endpoints accesses city traffic cameras, and these cameras could be very useful to our fleet of delivery drivers. But the data set is very large. We don't want to pull the whole thing every single time. That might be a waste of resources or processing power. So our workspace is going to build an SOQL request that pulls cameras only along the delivery routes using a function. So for context, Calgary weather is extremely unpredictable because of these warm winds called Chinooks. You might shovel your driveway in the morning, then have a nice sunny afternoon bike ride. Not only that, the city footprint is massive, so the north side of the city could have the weather on the left while the south is enjoying the right, almost, nearly. So for that reason, this is why our delivery drivers want a visual check on the road conditions for all of their routes. And our final result will be a KML layer that they can view in Google Maps or most car navigation software. So for every API workflow, we first take stock of our data and documentation to see what we're working with. And our workflow begins with a CSV like this for each delivery driver. Its columns have a trip ID and then some address information. And in our workspace, we've already turned the CSV into routes in our FME workspace with the Google Maps API, and that's kind of where we're starting off, but I'll just quickly do a high level of overview of what we've done. So here we can see our routes on the map, maybe. There we are. They'll just flash, and you can see we have different routes there. And they also have trip times and duration, distances. And to do this, we just submitted those addresses to the Google Maps API with a GET request using coordinates, and it returns these routes in its response. This is a lot like using Google Maps from the app. And if you're interested in this part of the workflow, since we're not going to get into it too much today, we're just going off of these routes. This workspace will be available after the webinar, and please look out for a new tutorial showing how to do this on our knowledge base soon. But our main challenge is the Socrata API, which comes next. It's along these line features, and I'll just turn off the map so that you can see them better. There we are, that we'd like to pull traffic cameras for. So we have geometry, and we want to make a query that uses this geometry inside. So I'm going to go over to the City of Calgary website. And the City of Calgary's website is, their open data portal is hosted on the Socrata dev site. But first we can just check out these traffic cameras. And you can see there's a little more than we need for those routes. And we don't want to pull all of these every time. So we go over to the dev site. And the first thing we see here on the traffic cameras endpoint is the primary endpoint here for accessing the traffic cameras. So we can identify this simple example of a SOTA request. We have our domain, our resource folder, and a data identifier for the cameras. And Socrata documentation is really useful because we can test out our calls in the browser. And just a tip, we could also drop this URL into a HTTPCaller or Postman to test out calls before we get started on more complex. But for now, we can see the response here, and the complete data set has been returned. We can see it's quite long, and that's why we want to build a query. But looking at the response here, we can see that we get a JPEG URL, a description, a quadrant, some text location information, and a point with coordinates. And if I navigate to this URL, I can see this is where Calgary is hosting live images, as it was just updated a moment ago. And this image is what we want on our map. So if I keep scrolling, Socrata lists the fields for the traffic camera data set that we can search. And these are the same fields that we see in our API response. We want to compare our routes to the traffic camera points. So we can use the point field, which we saw in the response had geographic coordinates. So this is an example that builds on the last, except for now we have a where clause and we have a function. And in here we have our point geometry, our point field, and some coordinates. So we want to do something similar to this. So let's see what other functions are available to us. And in the documentation for the point field, we get even more information. And we can see that it lists every single function that works with this field, and we have to decide which best suits our needs. So our routes have an irregular shape, so we can use the within polygon function. And here we're in the within polygon function now. We can see that it uses a where parameter, so that's our clause, and that it accepts both a location or point, so we have a point, and a multi-polygon. And its function is to filter the point field by that polygon. You can also see that that multi-polygon must be in well-known text. This is a great format for the web because it's so compact. And this last example here is pretty much the prototype we're going to follow going forward. The where clause is followed by a within polygon function, and then we have our two parameters. Ours will be the point field because that's what we saw in the traffic camera documentation, and the multi-polygon will represent our routes. So let's go see what this looks like in practice. Back in our workspace, I just posted an example of that request up here, a little simplified, just so we have a point of reference. So our routes are currently just line data, as we remember, and we need to create multi-polygons so we can use this with the within polygon function to search for cameras along those routes. And if I open up the second part of the workspace, we can do this with the buffer transformer. So I've set it to around 50 meters around the road. And now we can see our routes have polygons. But this function specified that it needed a multi-polygon, so we can do this by aggregating our polygons by each leg of the journey. Remember, there is trip A, B, C, D, and now those are multi-polygons. And we're pretty close to completing this request, but an API can't read geometry features like FME, so we need to turn that geometry into a text attribute so that it can be read by the API. And as a tip, when working with Socrata or spatial APIs in general, the geometry extractor transformer is going to be your friend. We can create a new attribute and choose how it is encoded. So in this case, I've named my geometry attribute the buffered route, and the encoding is going to be well-known text, like it said in the documentation. You can see we have lots of choices here that would work with a variety of APIs, I'm sure. And the result is we now get a multi-polygon and well-known text. And we can see that it's just kind of a wall of coordinates. And these are the moments I'm grateful for FME to do the work for me. But basically, this represents one of our buffered routes. So that's what we're going to submit to the API. And inside the HTTPCaller, we can set the rest of the request up. So for each trip, we have our URL, our resource, and our camera endpoint or dataset identifier. And we can also use our where clause in the query string parameters. And in the value, we're going to put our function in there. So we have our within polygon function. We're going to search the point field of all the traffic cameras, and we're going to use our buffered route as a filter. So basically, we're pulling all of these points from within these buffered routes. And our result is a response body that looks a lot like what we saw on the documentation. We have a URL for the camera, a description, quadrant, location, and coordinates. We can parse this with the JSON fragmenter. And inside, I've just built some queries and exposed the attributes I'd like, which is the location, the URL, and we have some point data and the feature information that we can use in our next step, which builds vertexes for each of the cameras. And we can see our cameras floating around in space, and now we can begin to visualize our cameras on the map. If I turn the background map on, these cameras are scattered kind of around our routes in Calgary. Just takes a moment for the map to load there. So our final result is a KML layer. So now we're on to the fun part. Basically, we can feed both of the camera features and our original route line features here into the KML feature colors setter. So I'm just assigning a unique color to each trip on the delivery destinations. And with KML, we can actually use HTML to configure their pop-ups. So when you click on a feature, it'll pop up with some information. So I just split out the features again. So we have our cameras up here and our routes down there. So we can give them unique properties. And in the camera settings, I have used the HTML, just give it a trip name and a camera URL, and that's going to be our picture. And when we click on the camera, that should pop up. And then for the routes, just some information about the routes. So we pull the business name and the address from our CSV and the distance and the duration from the Google Maps response. So the last step is just to write the routes and cameras out to a KML. To kick off this workspace, the delivery drivers would just submit their CSVs to maybe a web app or something, and it would produce a KML. So we can look at what that might look like. And in Google Maps, you can load in your KML files. So I will import our result. And the end result is something that my drivers can load into their navigation software. So we can see on the side, each trip of the journey has its own layer. And by clicking on each feature, we get some information about that route. So here we have the business address, distance, trip duration. And the best part is because the city of Calgary is hosting these images, my drivers can look at this file at any point of the day and see real-time road conditions. And right now, it looks like a beautiful day in Calgary. So this concludes how we can use FME to build spatial queries and easily submit them to Socrata or any other database-like APIs. And for now, I'll pass it back to you, Sienna.
Thanks, Sinai. All right, now we're going to look at what if API documentation is written in curl. So in our last webinar, we said, oh, if you're confused at all, just look at the API documentation, the HTTP calls will be there, and you just simply transfer that over to FME. However, sometimes it's not that simple. API documentation is mainly written for developers in mind, people who do use code to make these calls. Not everyone knows the power of FME and how easy it is to use another program like FME instead of writing your own script. So sometimes API documentation can be written in either curl or a programming language. I got this example. It's on the right from the question of the week. It's something that Mark Ireland does on the community where he posts questions of the week, kind of hard questions that might not have the best short answer, and he takes a deep dive and he looks into them. So if that's something that you weren't aware of that he does, I'd definitely take a look. So what is curl? Curl, it stands for client URL. It's a command line tool that is on most machines. It's on Linux, Windows, or Mac. It's typically used for making HTTP calls, but it can do much more. And FME actually uses it behind the scenes in the HTTP caller. The easiest thing to do if you encounter curl in your API documentation is import it into Postman. So if you don't know about Postman, it is a free tool that allows you to test out APIs. Anyone can use it. It is available on Windows or Mac. And all you have to do here is click the import button and it'll automatically transfer that curl into an HTTP request that you can then paste into your FME. So it's super simple to use, and we'll be going over that in the next demo. If you are someone who likes to take a deeper look at things and really understand them for yourself, then you can go to the curl documentation. The curl documentation is available online as curl is a free to use tool as well. One thing to note, if you do decide to go into the documentation, is it is case sensitive. So what's considered a capital X and a lowercase x are different, and that can be kind of confusing if you're just searching for things. But in our case, we're looking at the HTTP method. The header is the capital H, and the capital F counts as form data. So this could be under content type multipart / form data. So I just wanted to introduce the demo here. So the documentation with curl that I was using, transforms black and white images into color images. So this is a picture of my puppy that I took from black and white and I transferred it into color. I know that for most people, this isn't a relevant business case. Not everyone has black and white photos of their dog that they're going to transfer into color. But the kind of mechanisms that we use to transfer this photo into a color photo can be applied to so many good business cases. Let's say you have an API that does raster object detection and you're detecting stop signs places. The same methods of uploading that photo and downloading that photo is universal in the HTTPCaller, so that's something you could use. Another great example is if you're detecting cracks in pavement. Now, let's say you have a bunch of drone imagery of pavement, you want to know where your cracks are. You could use something similar with a different API to detect these cracks. So just because this is kind of a sillier example, doesn't mean that there could be some really good business cases behind doing a similar workflow. I also wanted to touch on uploading attachments. So there are many ways to upload attachments through the API, or through the HTTPCaller, but you need to read the API documentation to determine which one to use. The easiest thing to do is under body. So once you select post in the HTTPCaller, you look at the body section. You can say upload data, upload from file. Select your file and off you go. However, this won't work in all cases, particularly in our case for this API. It's using the multi-part upload. The multi-part upload works differently than how we upload when we say upload from file. So in this case, this will not work for us, and we need to go to the multi-part upload and then upload the image that way. And I'll show you exactly how that works. Next, you can also download attachments in the HTTPCaller. So when you look at the response section, it will say save response body to. Typically, that would be attribute, but all you have to do is flip that switch and say save the response body to a file to download a file directly in the HTTPCaller. It's important to note, sometimes you don't want to download the files right away, like particularly if you're working in with raster imagery, and maybe you want to do some transformation in FME before you write out that file, then it's better to save it to an attribute instead of downloading it and then trying to get it and reading it back into your workspace. It's just faster, simpler if you save it to a response body. But sometimes it's the end of your workflow and all you care about is that file, then you'd want to save that response body to a file. So let's take a look. So in this case, it's a photo processing demo. I have a series of photos I'd like to send to an API for processing. However, I'm not a programmer. I don't know how to use curl. How would I do this? So I'm going to use the combination of FME and Postman to break down this post request. So I can easily use this API in the HTTPCaller. So now I can automatically process all my photos without writing any code or using any command line tools. So let's take a look at this. First step, as always, is to go to the documentation. This documentation is quite simple. We have two options here. One is to post an image from an image URL. I don't have my images online, I just have them saved locally. So I'm going to select the bottom one. I'm going to copy that and go over to Postman. So in Postman, I have this import button where I can import curl. I just want to use the raw text. I paste it in there and I select this button to import. Now everything is all laid out for me. It only has one header, which is the API key, and then the body as well. So now I'll take this over and I'll transfer it into FME. So this is what it'll look like in the HTTPCaller. I have my request URL. I'm posting it. My header is set up here the same way it is in Postman. And now I'm going to go on to this form multi-part upload. So all I had to do, it typically would be specify upload body. I selected multi-part / form data. I got that name directly from Postman. The type I can set here is either a file or a string upload. I'm uploading a file, so that's what I'm interested in. And then I have my path here. This path is coming from the file and path names reader in FME. This just sends in path names instead of reading in a full file. It's super useful if you want to look at a lot of files at one time. So this would read in a whole directory of images. The next thing I have is to download the resulting image. So from the response, it will give me a URL. So this is the URL I can use to download my image. In the HTTP caller again, I want to save the response body to a file. And I'm doing a fan out here and telling it where to put it and what to name it. So let's take a look at how good this is. So it's going to take those black and white images and it's going to upload them using the HTTP caller. It'll flatten them out and write them as well. So here are the colorized images of my dog. You can see that there's some progress that could be made here. Maybe these aren't the best colorized images, but it's definitely a cool start. Next, I wanted to show off, so let's say you're not doing like a batch upload. Let's say you just want to make an FME server app for people to use. You're going to have to do this a little differently. So using an FME server app, you're not going to use the file and path names reader. You want to use a parameter to allow people to upload a file. We can take a look at our user parameters here. And this dialog was created in 2021. 2021. And it's a great way to see an overview of your published parameters. So I just had a file type parameter that I'm using to get that file path. From here, I have the HTTP caller set up in the exact same way, but instead of having my file path come from the file and path name reader, I have my parameter set up. Next, I'm downloading the image, but I'm going to download it to an attribute instead of a file. I want to save that for a little bit because I need to write it out to an actual writer. So while the HTTP caller can write out files, it's not considered an actual writer. So if you're using the FME data download service on FME Server, which downloads the photos back to the user within a zip file, if you're downloading that file, the HTTP caller is not recognized as a writer. So when you go to upload the workspace, it'll say, there's no writer here. There's nothing for the workspace to download. So instead, we have to use an actual writer if you're using this on FME Server with the data download service. That's very easy to do. You download it to an attribute, use the raster replacer, which will take the binary we get from the service and create an image from it, and then just use a JPEG writer to download it. So let's take a look at what my new app looks like. So I didn't go through the FME Server app creation process. We did a webinar just last week about how to create an FME Server app, which takes you through step by step everything you need to know to be able to do that. So if you are curious about how this works, I definitely recommend checking that out. So now I can upload my file. I don't have any more photos of my dog, but I do have this old-timey black and white robot picture. So I'm going to upload that there. Click OK, it's going to run and it's going to return a zip file URL, which I can open up and see the response as well. So here is my colorized robot photo.
Okay, thanks, Sienna. Yeah, now we're going to shift our focus to how custom transformers can help you create more efficient workflows and use APIs to their fullest potential. So after working enough with web services in any context, you might notice that there's some repetition to your workflows. In Workbench, the classic sequence is an attribute manager, an HTTP caller, some JSON transformer, followed by maybe another attribute manager, not pictured. So across your workspaces, you may repeat the same sequence over and over again, maybe even hitting the same endpoint each time. Copying and pasting transformers technically could work, but creating a custom transformer is a much better solution. So what you can do is wrap up a sequence of transformers into a single custom transformer, and it is built to take an attribute, do some routine workflow inside, make an API call if you choose, and then return it in the result. So this is pretty much how your standard transformer works, or kind of like creating a small program in code. It does exactly what you want each time. So there's a lot of benefits to this. One is organization. So less transformers on your workspace reduces the clutter and makes them much more modular. This is because each small workflow is organized in a separate tab. Flexibility. So any custom transformer can be opened up and modified for different needs. This is especially helpful if you're frequently working with the same web service. So there might be different endpoints, but the formulation often remains the same. Efficiency, so adding a single pre-configured custom transformer to a workspace is a lot easier than adding many. And it's file-based, so it's optional to save the custom transformer to an FMX file external to the workspace. This maintains a master copy that will update any workspaces that contain it. And like in the name, it's custom. So when you create a custom transformer, you'll have full powers to give it a unique name and create its documentation. The possibilities are pretty endless here, and especially so when you're working with web services. There's an infinite number of APIs out there and an equal number of potential custom transformers. So you can access already made custom transformers from the transformer gallery inside of FME Workbench as long as you have internet access, or go directly to the FME Hub and explore what's available on there. Our safe team has made many, and there's tons submitted by the FME community. Making your own is super easy. You just select the transformers to include and right-click to start that wizard. And there's two major types of custom transformers to be aware of. Embedded saves the transformers within the workspace in a tab. But if you save it as linked, its definition is saved to an external file. So if that file is updated or changed, every workspace that contains the custom transformers will reflect those updates. So for our next demo, we'll show off what it looks like to make and use an API custom transformer. Let's say our organization is managing many workflows that result in a notification. We're using Twilio, an API that sends text messages. It often takes maybe 10 minutes to build and set up this Twilio request in our workspaces, and maybe others in our team rely on us to set up this request because they're unfamiliar with this API. So despite it not being difficult, we kind of wish we could just press a button and it would be done for us. So we can kind of do this with the custom transformer that's designed to send text messages with Twilio. So let's go look at our workspace. This is kind of the standard workflow here for sending a text message with Twilio. I'd have to configure the HTTP caller. It makes a post request to Twilio, configure all of these parameters like a post body and our authentication. We also prep the data to enter the caller. And we set up these JSON transformers to parse the response. So as we saw in our poll, this is a bit of a pain point, figuring out how exactly to do this and which messages to target. So it's not a long workflow, but as we can imagine, if we have to recreate it dozens of times and it was maybe much larger, which it could be, this process could become tedious. And if our callers would like to do this, but they're unfamiliar with the Twilio API or HTTPCaller, it's on me to set it up. So to create a custom transformer, all we do is we select all the transformers we'd like to include. These are the ones required. And we start the wizard. After we select create custom transformers, we can give it a name. We choose a category, which is especially helpful when it's updated to the web or to the FME hub. And we choose web for something like this because we're utilizing an API. And then we can create documentation to tell others how to use it, as well as a help page and some history. If we're going to be updating it or changing anything, we can let our users know exactly what's been changed. And just like regular transformers, they intake parameters, so we can have FME automatically set these up or manually create them after the fact. Once I hit OK, we'd have a custom transformer just like that. So we can look and see what that looks like. Down here, we have the official Twilio custom transformer that lives on the hub, official, unofficial. It has parameters that it intakes, and these would be all the parameters required to do this workflow. And it looks a lot like any other transformer except for it's green. So green signifies that it's embedded and that it's saved with the workspace. That's because I made a local copy. If you go to your FME Workbench right now and type in Twilio, you'll get a blue version because first you'll get that linked version from the web. But I wanted to look inside, and the workflow for the custom transformer is stored in this tab up here. And inside, you can look under the hood, adjust the call. Maybe Twilio changed how its responses come back. You can adjust the JSON parameters, and you can also adjust the user parameters that you enter into the transformer. So let's see how easy it is to incorporate into a workspace. So this is basically where we left off in our traffic camera workspace. So instead of writing out to a KML directly, like we did last time, we will compose a text message that sends a download link to our delivery drivers. But I don't want to configure another API call and add even more to this workspace. So I can take advantage of the Twilio SMS sender available on the hub. And to access that, I would just type it in. And we can see it's here, just like any other. We have our hub transformers here. So that would be a linked one. And since I've made it a local copy of Twilio, it's right here. We just click that and add it to the workspace and fill it out. So I've already done that. In this bookmark here is where I've configured it to send a download link. So we can see in the message, I've just put a sort of greeting and a download link for our drivers to use in their navigation apps. And to get that download link, I just wrote out the KML and I actually uploaded it to Dropbox so that we could have a public download link. Okay, so I'm about to get a little servery on you and I want to automate this. So we want these text messages to fire off every morning, hands off. So we can create an automation in FME Server that does that. And automations just use triggers to run workspaces for you. If you're not familiar with them, please check them out in some of our resources at the end of the webinar to learn more. This one is really just a daily schedule. Maybe it'll read and use updated delivery drivers CSVs. And at this point, we have it going off every morning at 6 a.m. And I can't show you what my phone looks like right now. So I'm just going to show you a clip to show what the end result would look like. So we get a text message, and they have a link for download, and they can open up that KML and view their routes on their phone. So the great thing about this workspace is it only took me about a minute to add and configure the Twilio SMS sender to my existing workspace. And I could do this throughout all of my organization's workspaces in the same amount of time. So if you'd like to use the Twilio custom transformer, it's available on the FME Hub for download, and please share some of your own creations on the FME Hub or in the chat. Maybe get in touch about any ideas you might have for a custom transformer if you're not quite sure how to do them. We'd love to hear about them. Yeah, this wraps up this part of the demo, and I'm going to pass it back to Sienna so she can show how to use custom transformers with Pagination.
All right, perfect. So we're getting close to the end of our webinar, and we just wanted to talk about pagination in the HTTPCaller. This was something that was very requested from our last webinar where we talked about REST APIs. So let's start with first, what is pagination? Pagination is when you take all your results and instead of returning all of your results in the response body, you're going to break it up by pages. This is commonly seen on websites as well. So you're used to seeing, instead of getting your 1023rd result all on one page, you're used to seeing multiple pages that you have to click through to get all of your results. This is so we don't either crash the thing that's receiving all this data, or it's also so we don't overwhelm users with a ton of information all at once. Pagination variables are much like you see on websites too as you click through the pages. So you can select what page you're on. You can also select how many results you'd like to return. So using pagination in FME, the FME Server REST API allows me to retrieve job statistics. However, I have a limit of 1,000 jobs I'd like to or 1,000 jobs I can retrieve at once. How do I make multiple calls to retrieve all the jobs that have run in my FME server? Typical examples of what you would see for variables in pagination is the limit. So how many results are you retrieving at once, as well as the offset. The offset is you're offsetting the page or offsetting the results. So if I want to retrieve the first 10, my offset would be 0. If I want to retrieve the next 10, my offset would be 10. My limit would be 10 as well. So you're just choosing what number to offset your results by. The big question is, do you actually need to loop? And the good rule of thumb is if you know the results ahead of time, you know how many pages you would like, you do not need to loop. You can use a cloner instead. The cloner will send multiple results, and you can use an expression evaluator to change around your variables. There's a great article on this called To Loop or Not to Loop. We're also going to have an upcoming webinar all about looping, when to use it, when not to use it. So keep an eye out for that. But sometimes you do need to loop. Sometimes you don't know how many pages of results you'll need to go through. And that's when custom transformers come in handy. You can easily create a loop in a custom transformer just by right-clicking and say loop to here. Important looping considerations is without the right logic, you can easily create an infinite loop and you'll have to manually stop your workspace. Typically, you want to avoid blocking transformers as much as possible. If you use a blocking transformer in a custom transformer, it'll have to be a linked transformer. And if you do that, it just makes it much more difficult to troubleshoot because you won't see the results in real time like you would if the feature caching is enabled. I'll also set the HTTP concurrency to 1 in your custom transformer. So I'm going to go through and do a quick demo on what pagination can look like. This workspace will be available for you to use. So here is my custom transformer where I've enabled looping. Here is what it'd look like if I do not have my loop fully enabled. So here I'm trying to get the dates or the jobs by a date. So I'm only looking at today's. what happens is my HTTP caller will get 1,000 jobs. It'll break down those 1,000 jobs and then test them to see how many jobs are within the date I selected. If they're not within the date, it'll go to the failed port and then write out everything that's passed. The key here is my sampler. It will only grab 1 out of every 1,000 jobs. So if all of these jobs have passed, I know I need to restart my loop, and then I will. If things are not sampled, then my loop stops. So let's take a look at what this will look like if I do add a loop. So I'm just rerunning this now, and now it should loop. As you can see, I'm processing my 1,000 jobs, and it's going to loop back. That's thanks to my sampler and the loop to here, where it's going to end up again, and then it's going to resubmit that job. So I'll include this workspace so everyone can take a look at it. It's also available just on FME servers in general. If you look at the dashboards, this is an example from the dashboard utility. There's also some great examples in the FME Desktop Advanced course. So some tips and tricks when working with REST APIs. The documentation should tell you everything you need to know. Using an external tool like Postman is key for testing out workflows. It keeps things really simple before you transfer it to FME. Typically, I like to start really small. I like to take an example directly from the documentation and test that out, and then build complexity on that. After that, developer tools are a great way to see what's going on in the browser if you're doing some kind of deeper debugging, as well as Fiddler can be used to detect network issues. All right, so if you want to get started for yourself, download the free trial, try out the workspaces from our webinar. We used a lot of free tools in this webinar, so I think all the APIs should be available if you get a free trial. Is that right, Snai?
Yes, I believe all of them have a free trial, and if not, there are usually similar alternatives, such as the Google Maps API. There are some open source directions APIs you can use. Yeah, I can link some of them in the chat.
Perfect. So we have useful links here afterwards when you get the slides. You can go through those. And we have 1 minute of the official webinar left to do Q&A, but we'll obviously stay on for longer if people keep having questions.
Awesome. Okay. Hang on here. We have a lot of great questions coming in. Let's see. I'm not sure. Yeah, if any jumped out to we answered some in the chat as we went along as well, so some of them might have already been answered. Okay, so question about making multiple calls using different values in a database. Hang on here, where'd that one go? Okay, here we go. We are using an HTTP caller to make a REST call. It takes a single value for each call. We need to make multiple calls using different values from a database table column. How would this be done?
I think you typically want to use, So as you're reading in the database, you're going to get a different feature for each database. You can use in the HTTP caller, you can use an attribute value in the URL. So for instance, if I open up, I'm still sharing my screen, right?
Yeah.
Yes.
Okay, good. Sometimes it's hard. So if I wanted to use, in this case, this is my offset variable, but you can use variables within the HTTP caller to change the actual call per features of your database. So I think that's typically what you'd like to use. And it's not just within the REST URL you can use this. You can also use it here. So here I have a query string parameter where I'm setting an attribute value, or anywhere in the HTTP caller, you can do that. So that's probably a quick and easy way of getting that done.
Yeah, that's a great question. And I would just add on, if you want to sort of add some conditionals or logic to which attribute gets added to that HTTP caller, I definitely look into some of our filtering and testing transformers like the tester or test filter to kind of create logic to which attribute is going to be entered into that HTTP caller. Yeah, that's a good question.
Yeah.
We've got another question here, Steph. So the documentation for APIs I'm currently working with appear to have a max number of calls per second. I'm interested in the concurrency parameter, but I don't see the duration is a component. Is there a way to manage concurrency with a time constraint, or is there a plan to account for that in a future release? There's a lot of that question.
Yeah, thank you, Dara. So in the future release 21.1, there will be rate limiting, which should solve that. However, currently your best bet is to use a decelerator to slow down your calls if you're really hitting that rate limit on the API.
Mm-hmm. Well, I think from my perspective, it looks like we answered most of them as you were presenting. I think we shared out the responses with everyone. So I think, yeah, questions have probably slowed down. Unless, Dara, am I missing anything?
No, I don't think so. Oh yeah, just one. Is the video going to be shared? Should be up on the website later,
Yeah,
I think.
Definitely. You can find all our webinars at safe.com/webinars, but we will email everyone as soon as we have it available. So you'll get a link to the recording, the slides, and the workspaces, which will hopefully give you everything you need to take the knowledge from this webinar and go apply it to your own work. But if you're short on anything, or if you find as you're going through it yourself, you have some questions, definitely reach out to us on the community at safe.com/community, or you can reach us on live chat, which is just on safe.com. But we'll definitely be sure to send out everything that we showed here today. Cool. All right, we got some nice comments from people too, thanking Deanna and Sinai for the webinar. Sounds like it was a really helpful session for a lot of people, so that's always nice to hear.
Mm-hmm. And like I said before, we'd really like to expand this series. So if you have any ideas for us or something that you feel is really missing in our knowledge content, please just let us know, either through the community or a live chat. There's lots of ways to get in touch with us, and we'd really like to help you guys out.
Absolutely.
Yeah, give us your feedback.
We also have, be sure to fill out the survey, because we're asking you some more questions on some of the resources that you find helpful or would like more of. So please fill out that survey so we can go and build up some more content for you and plan some more webinars. Great. Okay. Well, thanks so much, team. What I'll do now is I'll close the webinar down, but leave it running for another 5 minutes in case anyone wants to save out any links or chat in any last questions. We'll keep it up for another 5 minutes.